These examples go with lesson 6.3, sampling distributions and the central limit theorem. Example 1. A population has mean mu equal to 6 and a standard deviation sigma equal to 4. Find mu sub x and sigma sub x for samples of size n equals 25. Okay, our mu sub x, we are told, is just equal to whatever the mean of the population was. In this case, that's going to be 6. Our sigma sub x, we're going to have to do a little bit of calculations for. That's going to be the standard deviation for the population divided by the square root of our sample size. Now in this case, our standard deviation for our population is 4, and then our sample size is 25. So we have 4 divided by the square root of 25. Well, the square root of 25 is just 5, and then when we turn this over into its decimal form, it's going to give us 0.8. Example 2. A population has mean mu equal to 17 and a standard deviation sigma equal to 20. We're going to find mu sub x and sigma sub x for samples of size n equals 100. Again, our mu sub x is just equal to whatever the population mean was. In this case, that's going to be 17. Our sigma sub x is going to be equal to the standard deviation, in this case that's 20, divided by the square root of n, and in this case that is 100. The square root of 100 is 10, and then 20 divided by 10 is going to be 2. Example 3. A population has mean mu equal to 10 and a standard deviation sigma equal to 8. A sample size of 50 is drawn. Part A, find the probability that x bar is greater than 11. Okay, the first thing we want to check for is we need to make sure that our sample size is greater than 30. And our sample size being 50 is greater than 30. So that means that we can go ahead and use the normal curve. Okay, all right. The next thing we want to do is we want to be able to sketch things over here on our curve. So we need our mu x, which is going to be 10, because that's going to be our population mean right here. And we need to calculate our sigma x, which is going to be the standard deviation 8 divided by the square root of our sample size 50. And I am going to round this to 4 decimal places. And in my calculator, this is going to give me 1.1314. Okay, now so that I can put it over here on the normal curve, I'm going to need to convert these into z-scores. Now remember, our mean is going to have a z-score of 0. And we're going to need to convert to make a z-score for 11. Let's see. Z is equal to 11 minus 10 divided by our standard deviation 1.1314. All right, let me do that in my calculator. And this is giving me 0.8839. So we're not going to quite go all the way out here to 1. We're going to go just shy of it. And if we sketch in the area that we're looking for, that's going to be this area right in here, because it said we wanted to find the probability that x is greater than. So we're looking for this area back in here. Now we can put this into the graphing calculator to figure out what the area is back here on the left side. We can use the table A2, or we can use the calculator over in ALEKS, because there is a way to calculate the area of the curve, or the area under the normal curve, using the ALEKS calculator. I think I'm going to use table A2. Okay, so our z-score was 0.8839, but I'm just going to round that to 0.88, because remember, our table over here only rounds things to 2 decimal places. And it was positive, and it was on the right of the 0 of our mean there. So I'm going to scroll down here. I'm looking for 0.88. And let's see. Here is the 0.8 line. That's 1, 2, 3, 4, 5, 6, 7, 8. So 0.8106. That is the area to the left. That's going to be right in here, which means that the area that we're looking for, if we use our rule of complements, is going to be 1 minus 0.8106. And the probability that we are looking for is going to be 0.1894. Now, another option we had for doing this is we could have pulled up the ALEKS calculator, and we could put in our z-score here of 0.8839, and we might have gotten a more accurate answer from it. And I know that ALEKS is being a little bit finicky on some of these. So let's go over to the ALEKS calculator. All right, so here's my calculator. Move it around. Yeah, there we go. All right, down here, you'll notice we have P of Z less than or equal to. This is the part we're going to use if we want to find the probability that the area under the curve is less than or equal to some z-score. Now, in our case, we wanted 0.8839 because that is the score that the z-score that we calculated for it. So I'm going to put in 0.8839. Maybe there we go. And then if we push enter, that's going to give me an area. Now that area, remember, is to the left, and if I want the area to the right, then I'm supposed to do 1 minus that area. So let's see, we can do 1, oops. Guess we need to clear this out of here. 1 minus the probability of 0.8839. And that's going to give me 0.1884. And we got 1894. So they were kind of close. They were off by, you know, a thousandth of a point there. Okay. The other one over here, this is supposed to be part B, not another part A. Would it be unusual for x bar to be less than 8? Okay. Our threshold for unusual means less than 5%, less than 0.05. So if we find the area under the curve that's going to be to the left of 8, if that area is less than 0.05, then we can say, yes, this is an unusual occurrence. But if the area to the left of 8 is more than 0.05, then we say, no, this is not an unusual occurrence. All right, so first thing we're going to need to do is convert 8 over into its z-score. We're going to do 8 minus 10, and we're going to divide that by the standard deviation we just found, 1.1314. And on my calculator, this is giving me negative 1.7678. So if we put the mean right here in the middle, negative 1.76 is going to be somewhere in here in between 1 and 2. It's going to be a little bit closer to 2. Let's draw up our vertical line here. And since we're less than, that means the area we want is going to be back here and to the left. Like so. And this time I think I'm going to use the ALEKS calculator on this one. Now when we put it in there, the negative 1.7678, it should pop up and give me the area that I want right here because it gives the area to the left. So let's see. We want the probability of negative 1.7678. Enter. And there it is. We got 0.0385 if we round that to 4 decimal places. 0.0385. All right, so now we answer our question. Is it unusual? Well, yes, it is. This is going to be unusual. This is going to be an unusual occurrence because the area that we found, 0.0385, is less than our threshold for being unusual, and our threshold for being unusual is 0.05 or 5%. Example 4. A population has mean mu equals 47.5 and a standard deviation sigma equals 12.6. A sample of size n equals 112 is drawn. A, we're going to find the probability that x is between 45 and 48. Okay, first thing we want to do is check in and make sure that it's more than 30 so that we can use our central limit theorem. And n is actually 112, so that is more than 30. So we're good to use this. All right, the next thing we want to do is find out our mu sub x. Well, remember, that's just the mean of our population, which was given to us to be 47.5. And we want to find our sigma sub x, which is going to be the population standard deviation divided by the square root of our sample size. All right, and let's put that in the calculator and round it to 4 decimal places. And that gives me 1.1906. Okay. We're trying to find the probability that x falls between 45 and 48. So what I'm going to have to do now is I'm going to have to make 2 z-scores, one for 45 and one for 48. Now I'm going to differentiate between the two of them. I'm going to call z1. This is my first z-score. This is going to be 45 minus 47.5 divided by our standard deviation. All right, so my first z-score is going to give me negative 2.10. Now my second z-score, I call this one z2, and that's just because it was the second z-score I calculated. And this is the one where I'm turning 48 into its z-score. So we did 48 minus the mean divided by the standard deviation we found, and in the calculator this gave me 0.42. Now I have been rounding these out to 4 decimal places, but when I went out to 4 decimal places for both of these, they were 9s, and those 9s rounded up, so that's why these ended up being rounded to 2 decimal places. But It makes it easier to use table A2 if we want to, because these are already rounded to 2 decimal places. But I think I'm probably going to use the ALEKS calculator because it might be a little bit quicker. All right, let's graph this so we can take a look at the area that we want to find. The mean, right here in the middle, negative 2.1 is going to go just barely beyond the negative 2 standard deviation there. And then 0.42 is going to be not quite halfway between 0 and 1. All right, so let's draw in our vertical lines. And the area under the curve that I'm looking for is going to go from here over to here. Remember, when I'm trying to find the area under the curve that's between two z-scores, I have to subtract, because what's going to happen is I'm going to find the area to the left of 0.42, which is going to take me all the way across. And then I'm going to have to find the area of under the curve behind 2.1, which is going to take me from here to here. And then since this is the area that I was interested in to begin with, I'm going to subtract them, and those parts are going to cancel out and leave me with just the blue area right here. So I think the ALEKS calculator will do that for me. So we can do this all in one step. Let's see. We'll pull up the ALEKS calculator, and we'll clear this out. And I'm going to do the probability that z is less than 0.42, and then I'm going to subtract the probability that z is less than negative 2.10, and then we'll enter. And it gives me 0.6449 when we round this. 0.6449. Okay, part B. Would it be unusual for x bar to be greater than 48? Well, let's see. We need to know, let's see, 48 had the z-score of 0.42. Okay. Oops. The 0 is right here. 0.42 is going to be right here. And greater than that is going to be all of this area right in here. All right. We need to know the area to the right here. And I'm going to do this in the ALEKS calculator, because ALEKS is going to give me this side, and then I'm going to use the rule of complements and do 1 minus it to get over to this side right here. And then to determine if it's unusual or not, remember, we're going to check our threshold. Our threshold for unusual is 0.05 or 5%. So if the area that's colored in blue right there is less than 5%, we can say, yeah, this is an unusual occurrence. But if the area in blue is more than 5% or 0.05, then we can say, no, this is not unusual after all. All right, let's pull up the ALEKS calculator, and we'll clear this out. Now I'm just going to do this in one step. All right, we're going to do 1 minus the probability that z is less than or equal to 0.42. So remember, just this part right here is going to give me the area to the left. When I use the rule of complements by subtracting from 1, it's going to give me the area to the right. And that gives me 0.3372. All right, so I have filled in the area over here in the light blue area. This is 0.3372. And we can answer our question out. Is it unusual? No, this is not an unusual occurrence, because the area that we found is actually greater than our threshold for being unusual, which is 0.05.